morning, ladies and gentlemen. We from Group 4 would like to present a video today regarding the previous experiment we did, which is the last experiment for this course, which is the climbing film evaporator. So now, ladies and gentlemen, what is evaporation? Evaporation is a process of separating the vapor from the solution that we have initially at the boiling point of the solution to get a more concentrated solution, which will be the end product. There are various types of products that can be achieved by using this method. So the device that is used for this evaporation process is called an evaporator. And this whole process is being done with the aid of shells, tubes, and various pumps. The main evaporator that is being used in this experiment will be the climbing film evaporator. Climbing film evaporator is just one of the many types of evaporator that is being widely used in many industries. So ladies and gentlemen, what is a climbing film evaporator? Climbing film evaporator is a unique type of evaporator that can operate in such a condition that can provide a high heat transfer coefficient and also a lower residence time to get the end product. So one of the climbing film evaporator, which is also the evaporator that is used in this experiment, will be the multi-tube climbing film evaporator. This multi-tube climbing film evaporator actually prevents this end product to get denatured when it's exposed to longer heat exposure. So ladies and gentlemen, by using this multi-tube climbing film evaporator, you can actually provide or achieve the optimum temperature and condition of the end product without taking out or without destroying any of its natural content, minerals, vitamins, and so on. So ladies and gentlemen, this climbing film evaporator can be operated as a batch and also continuous conditions, which is a very advantageous move for various industries such as sugar industries, thickening milk industries, concentrating fruit juices, and also desalination, which is currently being implemented in many other countries which are having scarce rainfall and also at the same time very near to the seawater. So when we take this mixture of solution with water and also the end product that we have, we actually use this climbing film evaporator to separate these two mixtures by using condensate, concentrate, and also evaporate to achieve our concentrated solution, which is our end product. So the main advantage of using this climbing film evaporator will be that it will provide a shorter residence time and higher heat transfer coefficient, and also it can be achieved, or the end product can be achieved in a very reduced evaporation temperature. And also this climbing film evaporator can operate under vacuum condition, where a vacuum pump is attached to this evaporator to make sure that the pump is used to set to a very negative or low pressure, which is easier for it to achieve a desired product without using a very high temperature. And this is why it will not destroy contents of minerals or any other useful content that is inside the product.
The objectives of this experiment are to observe the effect of evaporator pressure and evaporator feed level on a batch film evaporator operation. This experiment is divided into two parts. Part 1 is for the effect of evaporator pressure, and Part 2 the effect of evaporator feed level. For Part 1, the procedure is as follows. First, allow the flow of cooling water. Second, record the reactive index value of the feed stream. And then you turn on the pump and set the level of potassium manganese to 25 cm. Very carefully open the main steam valve and at the same time close the steam purge valve. Start the stopwatch timing. Observe the first bubble appearance and record the time taken. Record the time when the solution has boiled, which means when there is formation of many bubbles. After 20 minutes, close the steam supply valve and open the steam purge valve at the same time. Collect the samples of the evaporator, concentrate and condensate. The first sample taken is the condensate, which can be taken by easily opening valve 12. The second is the concentrate. Turn on the vacuum pump and the liquid will be transferred to the condensate receiver tank 2. After all the liquid has been transferred, collect the concentrate sample. The third sample is the evaporator sample. And finally, measure the volume and record the refractive index of all samples. Return all the samples to the feed tank. Now, repeat from step 3 with additional pressure of pump. Turn on the vacuum pump and set at the negative pressure 200, negative 400, negative 600 and negative 700 mmHg. For part 2, repeat steps 1 to 13 with different feed level of 50 cm, 75 cm and 100 cm.
And now we will be discussing the results of our discussion. In this experiment, we have the pressure variation and its effects on evaporation rates. From the graphs given, we observe the pressure decrease from ATM to negative 200 mmHg and negative 400 mmHg. We found that the time for the first bubble and the boiling time to decrease as well due to the vacuum conditions. In addition, it reduces the amount of heat needed to boil the liquid itself. These reduced pressure heating conditions are optimal for heat sensitive materials due to the reduced heat input. For the second part of our experiment, the feed level variation at constant pressure at the evaporator. From the graph, we observe that the feed level increases and the time for the first bubble and the boiling time decreases. Theoretically, it should increase due to the increase in feed levels indicates addition in volume of the liquid. Hence, time taken for the first time bubble and boiling time should increase. Some human errors may have occurred during this experiment due to the using of conventional stopwatches to record time intervals. The errors that may have occurred during this experiment, such as parallax error, they're taken during levels of the liquid. which have been wrongly interpreted, and inconsistency of pressure drop in the pump due it because it was manually controlled. Therefore, some variation and inconsistency of values that may have occurred. The third one is human error that has occurred due to recording time using conventional stopwatches, which may have not been very accurate.
To conclude our experiment for today, we can say that the rate of evaporation is depending on two criteria. The first one is the amount of vacuum pressure applied to the solution, and the second one is the level of feed of the solution. At higher pressure vacuums, where we apply the lowest negative pressure, it can be found that the rate of evaporation is faster. Thus, we can conclude that when we apply a vacuum pressure to the solutions, the rate of evaporation will accelerate, and also it will increase the effectiveness of the evaporation process. For the level of feed solution, based on the result obtained from this experiment, we can conclude that when the level of the feed is higher, the time taken for the solution to boil is faster. By means, when the level of feed is increased, the evaporation rate is also increased. To conclude, the faster evaporation rate occurs when the vacuum pressure is high, by means it has the lowest negative pressure, and also when the level of feed is higher. For this experiment, there are